Here we have m of x is equal to x to the fifth minus 6x to the fourth plus 10x cubed minus 11x plus 6. What is the degree of m of x, and what does this say about the number of zeros of m of x? The degree is the highest exponent of x, and so that's going to be right here. So we say that the degree is 5, and what does it say about the number of zeros? We know that there should be 5 zeros. So say the degree of m of x show how you will count the number of times the signs of the terms of m of x change. So we notice that the first term is positive, second term is negative, then positive, negative, positive. There's 1, 2, 3, 4, 5 terms, and in the original 1, 2, 3, 4, 5 terms. So now we look at the sign changes. So positive to negative, that's one change. Negative to positive, another change. Positive to negative, another change. And negative to positive, another change. That means there are 1, 2, 3, 4 zeros. So there are 4 sign changes. Okay, how many positive and negative zeros should you expect to find? Now, since there are 4 sign changes, then there will be 4 positive zeros and 1 negative zero. So and 1 negative. Now list all the possible rational zeros of m of x. To list the possible zeros of m of x, we need a constant term, which is 6. And we list all the factors of 6, which are 1, 2, 3, and 6. Also, we list the factors of 1, which is simply 1. And then we will divide the factors of 6 by the factors of 1. And so we will now have 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, and 6 over 1 is 6. And we take the positives and the negatives. So this list contains 1, 2, 3, 4 positives and 4 negatives. Okay, so now we are asked to show complete work in finding all the zeros of m of x using synthetic substitution. So now that we know that there are 5 zeros, 4 positives and 1 negative, and we have a list of possible zeros, we can start searching for the zeros. So we're going to use synthetic substitution. So we are going to take the coefficients here. So we start off with 1 for x to the 5th, then negative 6 for x to the 4th, and then positive 10 for x cubed. Notice that there is no x squared, so we're going to take 0 for x squared, and then negative 11 for x, and then 6 for the constant term. So when we list our coefficients, we should have 1, negative 6, 10. So 1 for x to the 5th, negative 6 for x to the 4th, 10 for x cubed, and then we have to put 0 for x squared, and then negative 11 for x, and 6 for the constant. So we have to make sure that we insert 0 x squared right here, and make sure that it's reflected here. So now we can start searching for the 0. So we can start by trying out if 1 is a 0. So we bring down 1. So bring down 1. 1 times 1 is 1. Put it here. Negative 6 times 1 is negative 5. Negative 5 times 1 is negative 5. 10 minus 5 is 5. 5 times 1 is 5. 0 plus 5 is 5. 5 times 1 is 5. Negative 11 plus 5 is negative 6. And negative 6 times 1 is negative 6, giving us a 0. So we found our first 0. And then we need to find another 0. Sometimes we have to check if a 0 repeats, so it's okay to try a 1 again. So we'll have here, okay, we bring down 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. Negative 4 times 1 is negative 4. 5 minus 4 is 1. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. And we got another 0 here. So that means 1 is a 0 of the function. Okay, so now let's see if, let me bring it over here. Maybe I could just move this up. Okay. Now let's try if 1 will work again. So we'll have here okay, so we bring down 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. Negative 3 times 1 is negative 3. This gives us negative 2. Negative 2 times 1 is negative 2. 6 minus 2 is 4. So 1 is not a 0 anymore. So it's a 0 2 times. Therefore, we're going to try something else. Now let's see if negative 1 will work. So we bring down 1. We multiply 1 by negative 1. Negative 4 minus 1 is negative 5. Negative 5 times negative 1 is positive 5. 1 plus 5 is 6. 6 times negative 1 is negative 6. We found our third 0. Now, we are looking for 5 zeros, 4 positives, and 1 negative. So we already have found that 1 negative, so therefore, we're not going to try another negative. We're going to test positives only because we found all the negative zeros already. So let's try this time. Let's try if 2 will work. So let's see if 2 works. So bring down 1. 1 times 2 is 2. Negative 5 times 2 is negative 3. Negative 3 times 2 is negative 6. And therefore, we're going to get another 0. And so we found 4 zeros already. This is the last linear factor that we could find. So we'll just take this in. Okay, the 1 is the coefficient of x, so 1x, and this is the constant term. So 1x minus 3 is equal to 0. So we'll add 3 to both sides. X equals 3. So the zeros of the function are 1, 1, negative 1, 2, 3. So this means that since 1 is doubled, it's a double 0, that the graph will bounce at 1. But we'll cross the x-axis quickly at negative 1, 2, and 3. Okay, so now we are going to write m of x in factored form. So m of x is equal to, okay, since 1 is a factor, and rather, since 1 is a 0, then x minus 1 is a factor. And because 1 is a 0 2 times, we can just put here squared times. Negative 1 is a 0, so x minus negative 1, which gives us x plus 1. And the next one is positive 2, so we will take x minus 2 And the last one is x minus 3. So this is m of x in standard form. Now the leading coefficient is 1. If we go back, since the leading coefficient of m of x is 1, that is the value of a here. This is also 1. Okay, so this time we want to use direct substitution to find m of negative 2. All right, so we have x to the 5th minus 6x to the 4th. So let's write that down first. M of x is equal to x to the 5th minus 6x to the 4th plus 10x cubed. Okay, let's double check if we copied correctly. So yes. All right, so now we want direct substitution to find m of negative 2. So we'll have m of negative 2 is equal to negative 2 to the 5th minus 6 times negative 2 to the 4th plus 10 minus negative 2 to the 5th is negative 32 minus 6 times negative 2 times negative 2 times negative 2 times negative 2 is 16 plus 10 times negative 2 times negative 2 times negative 2 is 8. Negative 11 times negative 2 is plus 22 plus 6. Okay, so this becomes negative 32 minus 96 minus 80 plus 22 plus 6. Now we have 1, 2, 3 negatives, so we add all the negatives and then add all the positives. So 2 plus 6 is 8. 3 plus 9 is 12, plus 8 is 20. So negative 208 plus 22 plus 6 is 28. So 208 minus 28 is negative 180. So m of negative 2 is equal to negative 180. Now, we can also find m of negative 2 by using synthetic substitution. So we'll take the coefficients 1, negative 6, 10, negative 11, and positive 6. Since we want m of negative 2, we can also we can put negative 2 in here. So we bring down 1. 1 times negative 2 is negative 2. Negative 6 minus 2 is negative 8. Negative 8 times negative 2 is positive 16. This is going to be 26. 26 times negative 2 is negative 52. So this will become negative 63. 1, negative 2, negative 8, positive 16, 26, negative 52. So 63. This is 126. So this is only 132. So what happened here? This is 2 to the 5th. Oh, we forgot that there's a 0 here. Okay, so instead of 1, negative 6, 10, negative 11, we have to put a 0. Then negative 11, then 6. Now we can find m of negative 2 using synthetic substitution. So we bring down 1. 1 times negative 2 is negative 2. This is negative 8. This is positive 16. This is 26. 26 times negative 2 is negative 52. 0 minus 52 is negative 52. Negative 52 times negative 2 is negative 56. Now this is negative 67. And 2 times 7 is 14. Carry 1. 2 times 6 is 12 plus 1. Plus 1 is 13. Okay, 767. So 134. And 134 plus 6 is 140. Okay, they don't match. So what happened? Negative 2 to the, okay, to the 5th, negative 32. 16 times 6. 10 times negative 8. And negative 11 times 2, and then 6. So negative 32, 96, negative 80, positive 22, and positive 6. So 2 plus 6 is 8, plus 0 is 8. 3 plus 9 is 12, plus 8 is 20. 20. So negative 208 plus, this is 34. No, 28. Why am I not? So here, so nothing is wrong here. So somewhere here there's a mistake. So 1 times negative 2 is negative 2. This is negative 8. This is going to be 16. So we add, it's going to be positive 26. 26 times 2 is negative 52. Negative 52 times 2 is 104. So there's the mistake. So this should be now 52 times 2. That's going to be positive 104. And 104 minus 11. Okay, so 4 minus 1 is 3. 10 minus 1 is 9. So 93 plus 11 is 104. Okay. 93 times 2. Okay, 90 times 2 is 180. 3 times 2 is 6, so 186. But because I'm multiplying by negative, it's negative 186. Oops, 186. All right, so, okay, 186. And 6 minus 186 is negative 180. So now we got the same answer. This is the value of m when x is negative 2. The same as this. So this one is direct substitution. This one, synthetic substitution. Okay, but you are asked only to do the direct substitution. I just wanted to show you that you can find m of negative 2 by using synthetic substitution. All right, now let's sketch the graph. So first we want to get the y-intercept, and the y-intercept is m of 0. So if we plug in 0 to x, these are all 0, 0, 0s, so m of 0 is 6. The y-intercept is at 6. Okay, so we got the x-intercepts and the y-intercepts, so we're ready to graph. Okay, so the zeros are, so the zeros are 1, 2 times. So let's just so zeros are 1, negative 1, 2, and 3. And the y-intercept is 6. So the graph has to go to 1. And then since 1 is a double 0, the graph will bounce here, but needs to come back. 2 is a single 0, so it's going to cross the x-axis there, come back for 3, and then 3 is a single 0, therefore it's going to cross the x-axis. Okay, now this graph is going to come down to get to 6 to negative 1, and then it has to cross the x-axis at negative 1, and so it will just keep going down. This is a sketch of the graph.